In this video, we are going to look at microservices, one of the most talked about architectural styles of the last decade. We will cover what problem they solve, how they are structured, how a request moves through them, and the real trade-offs you need to weigh before choosing this path. Imagine your entire application, user accounts, billing, search, recommendations, notifications, all compiled and deployed as a single program. Early on, that is fine. But as the system grows, a bug fix in one corner can silently break something in another. You cannot scale just the busy parts, and 10 teams stepping on each other in one repository slows everyone down. The monolith has become a liability. Think about the difference between a single large restaurant and a food court. If the one restaurant has a problem, every customer goes hungry. But in a food court, the burger stall, the sushi bar, and the coffee stand each operate independently. One stall closing does not shut down the others. Microservices apply that same idea to software. Each capability is its own independent unit. Here is what a microservices topology looks like. At the top is the client, a browser or mobile app. Below it sits an API gateway, which is the single front door for all incoming traffic. It routes each request to the correct service. Below the gateway are the individual services, orders, billing, and notifications. Each service owns its own database. This is a core rule. Services communicate with each other, either by direct calls or by publishing asynchronous events. Trace a checkout request through the system. The client sends a request to the API gateway, which routes it to the order service. The order service saves the order to its own private database, then publishes an event called order placed onto a shared message bus. The billing service and the notification service each listen for that event independently. They react in their own time, with no direct coupling to orders. This asynchronous pattern is key. Each service stays autonomous. Microservices buy you independent deployment and fine-grained scaling, but they replace in-process function calls with network calls, and networks fail. You now have to reason about partial failures, data consistency across services, and distributed tracing just to debug one request. A monolith is dramatically simpler to operate and is often the right starting point. The trade is real. You pay in operational complexity to gain team and scaling autonomy. The biggest mistake teams make is splitting too early, before they understand the natural seams in their domain. Start with a well-structured monolith, let the business boundaries reveal themselves, then extract a service when a clear capability needs to scale or deploy on its own schedule. When you do split, resist the urge to share a database. Shared data creates hidden coupling that defeats the whole point of the architecture. To summarize, microservices decompose a system into small, independently deployable units, each responsible for one business capability and its own data store. That design unlocks team autonomy and precise scaling, but it introduces the full weight of distributed systems, network failures, eventual consistency, and complex observability. Understand the trade-off clearly, and reach for microservices when the scale of your teams and your traffic genuinely demands it.